Hi everyone, welcome to your week 2 video. This week we're going to finish up chapter 1 and we are going to go into chapter 2. As always, I've included all of the slides from the actual textbook company that cover all of this material. They do a really great job of going through and explaining everything step by step by step. I'm going to point out some of those highlights in those chapters. And if at any time you have questions about the material, please make sure you're reaching out to me. I can be reached by phone, by email, or by text. Check out my contact announcement, and that's where you can find my phone number. So let's go ahead and take a quick peek at what you're going to see this week. We're going to look at properties of real numbers. So things about how to find equivalent fractions, how to use the commutative and associative laws, how to use the distributive law. And using the distributive law to factor is going to be really, really important as we move on. So make sure that you feel very comfortable with that before moving on to the next week's material. So here is an example of factoring. And again, I'm going to just skip through the slides and hit on the key pieces. These slides are available for you to look at all of them. Factoring is just the opposite of multiplying. So what you're doing is you're just using that whole idea of the distributive property, but you're doing it in reverse. So we're going to look at what common things do each of those pieces of the expression. What do they have in common? So as you can see on this one, we've got the letter AB and the letters AC. What do they have in common? They have in common the letter A. We can pull that out and use the distributive property in reverse to show what's left on the inside. And you know, when you're using letters, I know it can be somewhat difficult, makes it a little more challenging. So make sure you're looking at some of these examples where you're actually seeing numbers as well. So let's look at this first example. When you look at this factor 6x minus 12, this first expression has a 6 and an x in it. The 12 could be a 6 times 2. So that's what they're looking at when they look at this solution right here. They're looking at breaking the 6x down into 6 times x, and the 12 is 6 times 2. You pull out that common factor, which in this case is the 6, and inside the parentheses, you're left with whatever was left over. So the x minus the 2. And it's minus because that was what was separating the two pieces of this expression. So make sure you're really comfortable with that. That's going to be really important over the next few weeks, especially when we get into rational expressions and things such as that. Section 8 is all about simplifying expressions and using order of operations. One of the properties you're going to look at is the property of -1. And basically what that means is when you take -1 times anything, it becomes the opposite of that. So that's another really important thing. And then order of operations is, of course, really, really important. I think I posted a picture for you in the discussion posts about something you might have learned way back when. Please excuse my dear Aunt Sally. So we want to do everything within the grouping symbols first. Then we do, so parentheses, that's where the P comes from in the mnemonic. Excuse is exponents, and exponents includes square roots because that's just the opposite of squaring something is finding the square root. So that is also considered an exponential expression. And then we do multiplication and division from left to right, and addition and subtraction from left to right. So again, rules for the order of operations are going to be key. And then chapter 2 is also going to be covered this week. You're going to look at whether or not a number is a solution of an equation, and you're going to solve equations using the addition principle. And I really like this graphic. This graphic shows you the fact that when we think about expressions, equations, we need to think of them as teeter-totters. The equals button means that the two things on either side are the same. And if you take something off of one side, you have to take it off of the other, or if you add something to one side, you have to add it to the other. And so that's why they're showing you the vertical way to do this instead of the horizontal way, because it really makes it a good visual for you. It's really easy to see what's happening. So you can see here on this one that, you know, you've got a -7 and a +7, so those go away and you're left with x. But if you're going to add 7 to one side, you got to do it to the other. The whole idea of if one kid jumps off the teeter-totter, you're going to lose the one on the other side too, right? So you got to make sure that you keep everything equal. When you look at an equation to determine what you're going to do to undo it, you always want to look and see what's happening to your x. In this case, we're subtracting 7 from it. So to undo, you're always going to do the opposite of whatever it says. So the opposite of subtracting 7 is adding 7. So that's why we're adding 7 on these. So keep in mind that we're always undoing. That's the second half of these solutions. So I really like this visual though. It really helps. So as you're working through all of these, you're going to see the addition principle, you're going to see the multiplication principle, and then you're going to use those two principles together. So how to undo with both. And keep in mind that addition and multiplication, we're also talking about, you know, subtraction and division too, because those are just the opposites of each of the others. Let's see. The only other thing I wanted to make sure to remind you of is to make sure you're watching and looking at my slides about the applications and problem solving. So this is just one example of a problem where you can take the algebra and translate it into equations to solve a real world problem. So in this case, I'm giving you a perimeter. Perimeter is the distance around an object, and it's a 2x4. So we know that the perimeter of the whole thing is 10. We know that the length is 2 more than the width. So I set the width equal to W, and they're going to be both W, right? Because they're the same. And then each of the lengths are going to be 2 inches more. So W plus 2. Then we're just going to take all 4 of those sides and add them together, which is what I did right here. So when you add them all together, you're going to then combine like terms, and then you're going to go ahead and apply those principles that we learned earlier on how to solve that problem. So again, please make sure you're checking these out every week and let me know what questions you might have by calling, emailing, or texting. Have a great week.